Okay, good evening, everyone. We will start in a few minutes. Just wait for the other students to come in. Because we have a quiz today, I've given you the task in your LMS, and also uh, in your WhatsApp. Okay, how do you do it? You will because you will use, although the task given is to use either Excel or R. I suggest you just use R with the book. So, but I will also give you the answer for using Excel, and then I will also give you the answer later how to use R. Okay, you just wait for a few more minutes so that I can break you into groups for you to do your task. And then how do you could do it? You should base on last week's notes that I've given to you. Yeah. Okay, good evening again. Okay, first I will brief you what we will do today. Today we will have a quiz. We will spend half an hour to do your quiz. I think half an hour is enough because there are just two questions. And then we will not discuss it. Actually, we not discuss it in the larger group, but I will break you into groups. So you will work out. I'll share my screen first. Okay. This is the task you're supposed to do. I will have given to you the question in your LMS as well as in your WhatsApp. So it's about this is not N. I need to change this. Okay, this is recently an urban university. Conducted the transportation survey as part of its commitment to reduce its carbon footprint. The survey was distributed to students, faculty, and staff members in order to learn the patterns of their daily commute. One of the questions asked, during a typical school week, how do you commute from home to school? Possible responses include drive alone, public transit, bicycle, walk, and others. So 600 people responded to the survey. Okay, this is the table. I'll show the table later. I've given you the table in Excel, but you're supposed to construct a frequency distribution. Okay, the notes have been given last week. We discussed about frequency distribution last week. You can refer back the notes that we have discussed last week. This frequency distribution and a bar chart using Excel and R. I will give you later on. I will give you the answer for R, but I will not give you the answer for Excel. Yeah, I will give you the answer for R. Okay, I will give you later on the answer for R, and then I will not give you the answer for Excel. And summarize the result. Compare the results obtained using Excel and results obtained. You don't have to compare this because you will just do Excel and then provide the comments. So the transit survey data is provided. That is question number one. Question number two is a researcher at a marketing firm examines whether the age of a consumer matters when buying athletic clothing. Her initial feeling is that brand A attracts a younger customer, whereas the more established companies, brand B and C, draw an older clientele. For 600 purchases of athletic clothing, she collects data on the customer's age. Yeah, so age equals 1 if the customer is under 35 and 0 is if it is above 35. And the brand name of the athletic clothing is given A, B, or C. A portion of the data is given here. So using Excel or RR, I will give you the question, the answer later. I will put it up in your LMS. But in this work today, you just use Excel to construct a contingency table that cross-classify the age between by age and brand. How many purchases were for brand A and how many purchases for customers under 35 years and old. So this, I'll show you the data. Okay. This is the data for athletic, brand A, B, C, and so on. So there are 600. And there are 600 here. Yeah, brand A, B, and C. Okay, it is in your LMS as well as in your WhatsApp group. Yeah. Okay, you discuss how to do this in your smaller group. I'll give you half an hour, but you and then you will submit it before the end of the trimester, before the last trimester. But you can discuss. You don't have to present this round. We don't have to present. This is another case. Okay, I'll stop share first. Then okay, that is, and then the other transit survey. Yeah? Transit survey. This is the other data given to you. Okay, that's good. The other data. Okay, this is the other data given to you. Okay. Do you just use Excel? And then so there are two questions, question 1 and question 2. I will break you into groups so that you can discuss with your friends, do it together, but you submit individually. Okay, stop share. Okay. There are 21 of you, so 20 of you, so I'll break you into 4 groups. You discuss, and then after half an hour, so let's say 8:10, 8:40, yeah, we'll come back, and then you don't have to present this round, but you will submit it on the last day of the last class, during the last class, which is on the, what is the date of your last class? Your last class should be on the 26th of July. Yes, together with the other assignments. Yeah. Okay. Any questions so far?
Yeah, Prof, for the submission, we just need to submit our Excel pivot table,
Yes,
is it?
you submit in Excel format.
Okay.
You don't have to write a report. Just submit your Excel file.
All right, sure.
Just forward your Excel file. Yeah, you upload your Excel file, the actual Excel file, because I can see the codes there. Okay, I give you the, assume this is 8:10, so I'll give you half an hour to discuss, 15 minutes each question. I think it's okay among you. So I'll break you into, I think, 5 groups. I think more students are coming. I'll break you into 5 groups so you can discuss. And then you discuss amongst yourself, but we don't have to, we will not discuss later, because after that, after coming back 8:40, I may give you 10 minutes break, and then we will continue with our next topic, which I have given to you, which is on text mining. We'll discuss on text mining. Yeah. Okay. Any question? Any question? Mariam, Aimi, Sherin, Shakim, Timothy. Okay. Okay.
No.
Yes. But I will give you the answer for R. You can submit either one, Excel or R. But I will give you the codes. I will upload the codes in your LMS. And after you have done this, you discuss in Excel, but R, I will give it to you later. Yeah. Okay. I'll break you to 23. I'll break you into 5 groups. Yeah. I'll break you into 5 groups. More students coming in. Okay, breakout rooms. At random, yeah. Breakout. Okay, join your group, please.
Hello, hi, Prof.
Yes, please join group one.
Okay. Got it. Just a bit late to the class. Thank you, Prof.
Okay. Yoga, please join room 4, Yoga. Azani, please join room 2 for discussion. Okay, I think everyone is back. Okay, can we just continue or do you need a break?
Break.
Break, yeah.
Nine, Prof.
Okay, give you a break. Give you a break, 10 minutes, 10 minutes, just 10 minutes, okay? 10 minutes break, okay. Okay, can we continue? Okay, you have done your quiz number 2, case study quiz number 2. There are two questions. So please upload the Excel file on the 26th of July, okay? Last day of our class, our last class. Okay, and I've also uploaded uploaded at the LMS the answer to the question using R, and then the one of question number 1 and also question number 2. Okay, but you need to upload the submit to me the Excel file, the answer I've given to you in PDF. Okay, we will continue with the next topic, which is
Table lesson, Bob. Put one corner. Right.
okay. I hope everybody can see the screen. Okay, this is yeah, business topic number 5. We'll talk about text analytics and text mining. Text analytics and text mining. So what is text analytics? Text analytics, okay, when we discussed earlier, when we talk about data, data comprised of structured data and unstructured data. Most of the data, I think 80 to 85% of data that we obtain unstructured data, and amongst the unstructured data, most of them text beside images, video, graphs, and text. So text mining is actually what is comparison between text mining and text analytics. Text analytics, we combine information retrieval and text mining. Information retrieval is something that you call, layman call search. Yeah, we call it search. But the technical name for search is actually information retrieval. We have data. I think the thing we mentioned earlier, we have data at the bottom, and then we have information on top of data. Data are something which is meaningless. They are just raw facts, doesn't provide any meaning. Where information, we combine data, we aggregate data, we got information. So information retrieval is another word, this the technical word for search. When you say about search engine, search is information retrieval with retrieval. And then combining information retrieval and text mining, we get text analytics. So text analytics is information retrieval combining with information extraction. Once you retrieve, you extract, you do data mining, and you combine with the web mining. Yeah, data mining we learned last week. We look into association, we look into cluster classification, and so on. Yeah, so this is okay. Now, so text analytics combines this knowledge discovery in textual data. It combines information retrieval. Information retrieval, you look into document matching. We do link analysis, search engine. And then we have involved the technology called natural language processing. Technology in language processing is involved part of speech tagging. Yeah, part of speech tagging, which is we look into components of parts of speech which is more related to, say, we break speech into noun, verb, adjective, and so on. That is part of speech tagging. And then lemmatization is actually processing of group of different components, different words in certain sentences we group together. Word disambiguation because words that we use have different semantics, so we disambiguate the wordings. And then we have data mining. We have covered classification, clustering, association last week on data mining. And then web mining involves web content mining, web structure mining, and web usage mining. So the tools that we the technologies or the tools that we use, the knowledge that build up to this text analytics include statistics, machine learning, management science, artificial intelligence, computer science, and other disciplines, linguistics, and so on. I think they left linguistic here. Computational, it includes computational linguistics. So 85 to 90% of all corporate data are somehow unstructured, comprised of unstructured data. So unstructured data increase every time. And then tapping of these information sources is needed in order for you to stay competitive. So it is about discovering knowledge from what you get in documents, what you get from the web, what you get from written materials. Yeah. So it is both data mining and text mining look into patterns, hidden patterns, yeah, novel and hidden patterns. So it is a automated process. I think I mentioned to you when we talk about data mining, and it's actually the business people need to understand what they are looking for. So I think we discussed about structured data and structured data before this. And then in order to perform text mining, we need to impose structure to the data and then mine the structured data. So we cannot actually mine unstructured data. We cannot mine unstructured data. So we need to convert this unstructured data with such as text into structured data first. So that is a process that we need to undergo in order to convert them. Okay, so what is the benefit of text mining? We can make use of text-rich data environment for such as law, yeah, court orders, or previous cases. For example, like in court cases, we also look at what do you call it? Precedents, yeah, precedent cases, academic research, finance, you can look into quarterly reports, medicine, you can look into discharge summary, you can use them for case-based reasoning. Biology, we can look into molecular interactions, technology, pattern files, you can search patterns, and then marketing and so on. So we can also use it for spam filtering, prioritization of email and categorization of email, and then you can use it for automatic response generation. Today we have this large language models, large language models. Today we also use it large language models or LLM, such as the ChatGPT, Bard, yeah. There is another one for Baidu. For Baidu, they also produce another one. Okay. Just ask me if you have any question. And then the application area for text mining include information extraction. We can extract information from documents, from articles, from written materials, from agreements, from contracts. We can do information extraction. We can also do topic tracking, monitoring topic that comes in news, in magazines, in any resources that we get. Summarization, where we can develop summary from articles, from theses, for example, from annual reports, from audit reports or whatever, and we can categorize the documents. We can do clustering of the documents. We can link concept between document to a document, or materials to written materials to another written materials. And then we can also involve question answering. For example, like I mentioned to you about large language models, like applying large language models like with ChatGPT and so on. ChatGPT is actually applying is text mining of the documents in their repository. And then text mining terminology. The terminology of text mining that you need to understand include unstructured and semi-structured data. I've mentioned earlier that most of the data are unstructured. Semi-structured comprise of structured data combined with unstructured data. And then corpus and corpora, this is the repository that you use for the purpose of your mining. You develop content into, you combine content, you build up content into a corpus or corpora. Terms is the term used, is the words or term used in the content, which is more of syntax in nature. Whereas concept is the concept to describe the syntax, which is we call it semantic in nature. It's much more semantic, meaning that concept is not is at the semantic level, term is at the syntax level. Yeah, so the study is called semiotic. There is a study called semiotic where we look into the syntactic, the semantic, and pragmatic of contents. Stemming is you identify root words. You identify root words from a derivative words, yeah. So some derivative words, for example, like terminology or mining, for example. Mining, the root word is mine, M-I-N-E, for example, yeah. So stemming stop words is actually you removing, you look into stop words for that. The and yeah, the and these are called stop words. The in English it's called the and and so on. With something like that. So these are stop words. Words that combine things, yeah. And then synonyms and polysyms. Synonyms with words with similar meanings. Polysyms with words which have multiple meaning. And then tokenizing is actually you break the components of text into tokens. So you phrase or you break them into tokens so you can code them. And then besides that, term dictionary is a dictionary, as in a dictionary or glossary dictionary that you put terms for words. Yeah, word frequency is how many times the word appears in certain documents. And then part of speech tagging, you tag the speech into sometimes we call it post tagging, POS tagging. Part of speech tagging, we tag the words with the noun, verb, adjective, and so on, with the stop words and so on. Morphology is the structure of the word. Term by document is actually you look into the document and then we break them into the term use, and then we calculate the frequency of the terms or occurrence metrics. And then singular value decomposition is the indexing of the semantic of these words that appears in certain documents. So the technology that applies in text mining is called natural language processing. So the text mining is similar like data mining, only that before we can mine the data, we need to prepare the data, convert the unstructured data, convert them to become structured data. So the technology is called natural language processing. We call it NLP, natural language processing. It is a combination of artificial intelligence and computational linguistics. So it comprises of linguistic people who break up words according to each language into their grammatical and semantic order, and then so that the computers are able to understand the natural human language. So it is compared to the old keyword processing, which is syntax, we are now using semantic-based text mining. So this is keyword, because earlier when we do search engine, we do keywords searching. So this is semantic searching. We have meaning-based searching. Yeah, so meaning-based mining instead of just keyword mining. Yeah. Okay. Natural language processing is about understanding what human understanding of the word. So natural language is vague, is actually context driven, meaning that in order to enable the computers to understand certain words. For example, like I think the most common words that you can see here today, for example, table. Yeah. So there are two semantic. Semantic one, we give one example, say, say, Roger, please bring me the table. So what do you mean by please bring me the table? Bring the table to me. Please bring the table to me. Yes, so there is one. It is a furniture or a diagram or a tabulate. Yeah, so there are two semantic. Yeah. So how does the computer know what does it mean by the word table here? Yes, so What does the word table means here? Yeah, so they have meaning, the two meanings. Yeah, they have. So we can see this meaning. The differences of meanings are called semantics. Yeah, so they have words that have multiple meanings. Yeah, words. Okay. So how will computer understand? One way is actually to have an ontology or taxonomy for the word. The lowest ontology is the glossary. Yeah, from glossary to the high-end ontology, which is we call first-order logic. Yeah, the high-end first-order logic, which can describe things according to the proper meaning. So in retrieval, they will use glossary or first-order logic, which is at sense level. And sense level to provide the meaning. So this is how the search is being conducted today. They call it semantic entailment. Yeah, we add semantic into the meaning as metadata. Yeah, so okay. Then challenges in the natural language processing is part of speech tagging. We need to identify the part of speech tagging. For example, I need to get some example for the part of speech tagging. Say here can be an example part of speech tagging. For example, here the cat sat on the mat. For example, yes, this is part of speech tagging. The cat sat on the mat. So this is the is a determiner. This is what we call a determiner. Determiner, and then sat. Cat is a noun. I think everyone knows that cat is a noun. Stat is a verb. Yeah, so this is a verb. Let me say, I need to have some drawing. Set is the verb. And then on is a preposition. The is the determiner again. Is a determiner. And then mat is a noun. So this is a tagging. So we can add in furthermore, for example, adjective, they can say the black cat sat on the green mat. So it can be adjective and so on. So this is what we call part of speech tagging. So this is the speech, the cat sat on the mat. Part of speech tagging, we break that. But in order to understand, we need to have this meaning. So this is the challenges. We need to break this component. So this can be done automatically in machine translation, in automatic speech recognition, in text to speech. Yeah, certain application we can be able to do this. And then text segmentation. In the text, we can segment the text. And then word sense is this ambiguation is like I mentioned to you, the word is have different senses, meaning that we at sense level, the semantic is different. We need to disambiguate the different meaning. So for example, I mentioned to you table just now. So we need to identify what kind of table does it mean. Code, what does it mean by code? C-O-A-T, or chair. Say for example, like so for example, like say Tommy. chairs the meeting. What does it mean? Tommy chairs the meeting. So chairs, the word here, chairs, they will have different, is it similar with, there are many chairs in the room. Yeah, for example, yeah. So there are many chairs in the room. So the word chairs here have different semantics. So you need to have sense level, word sense disambiguation. Yeah, so this disambiguate the meaning of this. And then related to syntax ambiguity. Syntax ambiguity is the syntax. Syntax is, like I mentioned to you, we have syntax, we have semantic. So syntax have different, have ambiguities. And then imperfect or irregular input, your audience or your customers put irregular inputs, and then speech acts. Speech acts sometimes, like, it's not a formal word, but it is an informal word that you use in your speech. I need to give some example. Yeah? I don't have offhand. Something that you call out in customary and so on, you call it. For example, like speech acts. For example, in Malaysia, for example, we call everybody uncle. Anybody older, we call it uncle, but they are not your uncle. For example, these are speech acts. Yeah. So, so the AI community, the dream of AI community is to have an algorithm so that it could automatically read and obtain knowledge from the text. So we are able to tag the speeches. We can break into part of speech. We can segment the text. We can remove word sense disambiguation. There is no ambiguity in the word sense. Syntax also, we can use the exact syntax for it, and then we can correct irregular input, and then we can identify speech acts. So these are the challenges in natural language processing. So these are the things that you find in your document. For example, in social media, the posting in the Twitters, posting in Facebook, Instagram, and so on. So we need to process them in order for the computer to understand and then further process it for the for mining purposes. When you talk about text mining, the goal here is about text mining. How do we mine the text? So one of the tools that we can use is WordNet. You can try WordNet. WordNet is from Princeton University. Let me see. Yeah, stop for a while. What time is it? Okay, I have to quit. Okay, I'll stop share for a while. I'll show you what is WordNet. Yeah, I'll open up my internet. It's from Princeton University. They have WordNet from Princeton. Okay, this is WordNet, and then how do we use? Okay. No, it's quite slow. Okay, but I'll just share you my screen. Okay, this is WordNet. So you can use WordNet. Yeah? You can use WordNet. Use WordNet online. So you can search a web. This is a lexical database for English. So you can even download the WordNet, and then the WordNet will help you out in identifying the words that you want to use. It is readable by the computers. It's readable by computers, so computers will be. This is meant for computers, actually, not for human. So you can search word, for example. Okay, you can see my screen. Yeah, for example, like what is the word for, say, so school, for example, SCHOOL, school. When you search word for school, It's still searching, waiting. So it show on. We can, I will not spend so much time here, but you can use at your own on your own. Just go for WordNet. WordNet is at Princeton University in the US, so you can use it to search words that you want to use in. But this is meant for natural language processing. Yeah. So I'll continue because we are short of time. Continue with okay. So one is WordNet, and then the other usage of this is a major resource for NLP. The other thing for the major usage in natural language processing is to do sentiment analysis. Sentiment analysis is to detect favorable and unfavorable opinion about your products and your services. So the sources to use the sentiment analysis is from your social media. So for example, people write about your products in Facebook, in Twitter, in Instagram, whether they like the product or don't like the product, or they put in TikTok, for example, about the product. So you can you can crawl and then do NLP processing, part of speech tagging and so on, break into contents, and then you mine them. You mine the content. Yeah. So you can see whether people like your product and doesn't like your product, and then how do they. Other NLP task categories include question answering, automatic summarization. You can have natural language generation and understanding. For example, like when you use ChatGPT, it recreate language which is common to human. You feel like it is human writing to you. And then machine translation, when you travel and then you can translate to Korean language, whatever language you can. Machine translation, and you can do foreign language reading and writing. You do speech recognition when you talk to your Siri, for example, or hey Google, and then they can recognize your speech and then respond to it. Text proofing, optical character recognition. You can write characters and they can detect what it is your character. It can be cursive character or block characters. There are two types of characters. We have CJK, Chinese, Japanese, Korean language, or you can have cursive character, which is Arabic, certain language have cursive character, or we can have block character, English, Roman characters, Roman characters. And then this is optical character recognition. Yeah? So this is a common NLP task. And then you have to text mining. The purpose of text mining, what you can do, text mining you can do in marketing application, enable better CRM. In fact, when Salesforce have a text mining application inside it, combined with sentiment analytics, they acquired Radius. Yeah, Salesforce acquired Radius some time ago.
Sorry, Prof. Sorry to interrupt.
Yes.
Sorry, Prof. I just wanted to know, for all this text mining, the data is already available in package that you purchase and do whatever you need to do for your own personal purposes, or there is always in the background thousands of people typing, creating codes, creating tests, or creating algorithms for this, all the explanation that you give.
Okay.
Always in the background.
Okay, the text mining, there are multiple different applications, many different applications where you use text mining. For example, you have a large repository. For example, we look at the case of ChatGPT. ChatGPT, everybody understands ChatGPT. ChatGPT has its own repository. They have their own repository. How do they get their repository? They gather all the documents, they form into one large corpus. So it is their own repository. They acquire the documents, we put into a large repository. And then when you ask question to the ChatGPT, so they will break your question into part of speech tagging and so on. And then they will try to understand what you are looking for, and then find the answer in their repository. They will process, they will do mining and then find the answer from their repository and give it to you. That is okay, that is one way. The other way is they will use big data, meaning that the repository are there in the web, and then they will do indexing, and then when you ask question, they will respond. But most of the time, they will have indices in their repository, whether it is from the web or from they have indices, and then they respond based on their repository. So they require a repository to answer to you. There are two things here. One is the query. The query it must be based on natural language processing. The thing that you write, meaning that when you put in your search engine, the thing that you write, they must understand you. For example, you say determination. Determination is not processed as determination. It processed as determine. They pick up the root word. They do stemming, the root word, and then they search for root word in the search engine. Or for example, you ask certain question in your ChatGPT, they will break it into parsers, tokens, and then they will process it in their repository. They have a large repository. Does that answer you, Jaime?
Yes, sir. Thank you, sir.
Okay. Okay, these are the text mining applications. For example, Salesforce, they use CRM, they acquire Radius. Radius is a sentiment analysis. What does Radius do actually? Radius will crawl, they will crawl, actually they subscribe. They subscribe to the crawlers that crawls Twitter, crawls social media content like Facebook, Reddit, and so on. And then they have these indices. From these indices is plural for index. And then they will search the indices. And then from these indices, they will get sentiments of what people say about your product. They like the product or don't like the product. They have what we call it a dictionary, for favorable dictionary, unfavorable dictionary, and then they measure, and then they put statistic on it, and then they provide it. And then they support the CRM, customer relationship management. So there are other security applications like deception detection, and then gene identification, research stream analysis that uses text. So they gather the text. The text in this form is actually the raw text of articles, books, raw text. But we do process them. We break into indices. We'll go later. Yeah, I'll go through later. Okay, let me clear this first. I'll go quickly. We can also do deception detection, mining for lies. We can also detecting testimonies of people. So, okay, this is one example, text-based deception detection. So we have statement transcribed. Statements are people's statements. When you do statements, we will transcribe for processing. And then for processing, the cues will be extracted and selected. We have part of speech tagging and so on. Text will be processed. The cue statement, text processing, the software will generate quantified cues, and then it will do classification models, and then it will be labeled. So to identify whether it's deceptive or not. They have trend. We look at trend. When you start mining, you will see trend. You can detect trends and patterns of deception, or whether people are lying and so on. Okay, this is the categories of linguistic features that use in deception detection. We look into verb count, noun phrase, average number of clauses, average sentence length, modifiers, modal verbs, whether it is passive voice, active voice, objectification, emotiveness, lexical diversity, redundancy, typographical error ratio, spatial temporal information. Spatial temporal information is space and time, yeah, location and time. Perceptual information, positive effect and negative effects. So this is the ways that they will look at it. It combines with studies of criminology and studies of linguistics. Yeah, this is some application case. It's actually in the book, so you can read the book. Okay, this is text mining for biology. This is your gene and protein. This is the ontology, and then the word, part of speech, and shallow parsing. Yeah. Okay, and then okay, I will not go through the question here. Okay, this is text mining. process, text mining process will involve extracting knowledge from available data sources. It combines structured data, unstructured data. Software will have their limitation, privacy issues, linguistic limitation, context-specific knowledge, and domain expertise and tools and techniques combined. And then 3 steps in task text mining is to establish the corpus. You asked, I may ask just now. So the corpus is in you. You need to have build a corpus or repository. For example, like when Google developed their BART, they already have their repository. Google have a large repository of indexes. Whereas when OpenAI develop their corpus, they acquire repositories, they build up their repositories. Google is actually, they already have large repositories. Same goes with Baidu. Baidu, I think they have Erin, I think something. So they have their large repository. So they will create term document metrics. Term document metrics is how many terms that you have. You have the terms and then you break into documents. These terms are in form of root words. And then you can extract knowledge by looking into novel patterns in terms of the term document metrics. So you can see, you can do problem specific classification, association, clustering, visualization. The thing that we did in data mining, but we do the same thing, but now we analyze text. Instead of figures, we're analyzing text. So first, we need to establish the corpus. Where do you get the corpus? Is from the web pages, short notes, email, voice recording. Voice recording will need to be transcribed. There is a technology called automatic speech recognition, ASR, to convert voice recording into text. And then we have textual documents. Yeah, XML files are the metadata. So you collect all these relevant unstructured data. We digitize, standardize the collection into ASCII, American Standard for Code of Information Interchange, and then place the collection in a common place. So that become your repository. This call it corpus. Corpus means body. So this is your repository. You can check with ChatGPT, for example. You can ask, what is the size of their corpus? Their corpus is very huge. Yeah, their corpus is very big. And then you create the term by document metrics. So investment risk, project management. This is if you are doing something related to this topic, but it depends. If for businesses, you may have financial. We can have break-even point and so on. So you look into what document mentioned about what, and then so that this term by document metrics. And then you should look into so whether you want to include stop words. Most of the time people exclude stop words. Stop words are the, and with, and so on. So this doesn't really have connotes any meaning for you to codify. And then you look into synonyms and homonyms, and then you stamp the words so that you have, for example, like certain words, differentiation, for example, it is differentiate. The keyword, the stem word is differentiate or difference. So what level of stemming you need to stem, and then you have you do row count, binary frequency, log frequency, and then you do the inverse document frequency. Inverse document frequency is by the document how many frequency that the words appears. So term document matrix is a sparse matrix. So you can use manual, you can get a domain expert to go through it, especially when you have different semantics. So different semantics is understood by the specific people of specific domain. So you can eliminate words with very few occurrences, which is might not be relevant, and then you can transform the matrix into a singular value decomposition as a SVD, which is similar to principal component analysis. And then you extract patterns. This is the thing that you do similar like we do our data mining that we learned last week. We do classification, we do clustering, and improving the clustering. With clustering, we can improve search recall and search precision, scatter, gather, and so on. Okay, the keywords that I want to show here, we are going to go quite fast. This recall and precision. Search recall and search precision. Whenever you type any keyword in your search form, yeah, search query, for example, you use Google, you type any keyword, you have billions of response. Yes, type say root, for example, you type in Google, and then let's see, let's go do it just quickly. Let's see, share, do I have my Google? Okay, let me see. I'll stop share for a while. I'll open up. I want to show what is the precision, what is a recall. Okay, say let's show my page. Share my screen. Okay. Say you type here, you type root, R-O-O-T, root. Okay, this is about 2.61 billion results. 261,000,000,000. Okay, this is called recall. Yeah, this is called recall. Yeah, search recall. Search recall. Okay, but the precision, it depends on the accuracy of the recall that is relevant to your actual search, semantic of your search, because root can be anything. Root you can see here, okay. You can see here, it can be root, and then it can, okay, this is meaningful root, and then Android image for root, and then they have many square root, for example, they have square root, and then what is the root for an Android device? This is, so it can be many meaning for the root, but you are looking for root in, say, or we call it mathematics. So you have reduced, so you want to see square root. So the recall, actually, the precision is based on the exact semantic that you are looking for. Recall is the norm word. Okay, for example, you put here root mathematics. This is a semantic entailment. You have to put root and mathematics, and then you have it have been reduced, but there can I think it's much better now. So the recall is better. The precision is better. The precision is better. Yeah. So how do you reduce precision versus recall? Okay, I'll go back to the screen now. So this is what it means by recall and precision. So, and then how do you scatter and gather? Query specific clustering. So this is query specific clustering is when you develop your query, how do you cluster them? And then how do you develop association? And then how do you do trend analysis? This is the process that when you do data mining of the text content. Yeah. So, okay, this is different. This is literatures. Okay, how do you mine literatures? This is example. And then sentiment analysis. Sentiment analysis is about gathering sentiments about certain product or even yourself. Some currently even politicians use sentiment analysis. For example, in the case of Cambridge Analytica and Facebook with Donald Trump, for example, he used a sentiment analysis to get information on what people say about him. So it has been used before, I think it's since 1990s, we have been using it to measure sentiments of products. But he being a businessman, so he used tools that we use to measure sentiments of products into measuring sentiments about himself. So that is no wrong about it, because if you want to go campaign, do you want to tell people about what they don't like, or do you want to talk about things that people like about you? So you use sentiment analysis to define what does people like, and then you can do your campaign correctly.
Sorry, Prof.
So, yes.
Sorry. So sentiment analysis, what you just mentioned. So this guy, Donald Trump, is predicting people's behavior. So wouldn't it be predicting analysis as well? Predicting
Yes.
is predict something.
Yeah, because what he does is actually he measures sentiment. That this sentiment analysis, the data come from social media. Social media, from Twitter and so on. So people write about him, or people write about issues. So for example, you go to Texas, Texas is bordering Mexico, they don't like people from that Mexican come into. So these are the issues that people in Texas talks about. So we analyze them, and then these are the sentiments that he want to talk in his campaign. So how does he know what to talk about? He measures the sentiments. So in marketing products, for example, you are selling food, for example, what does people like about your product? What does people don't like? What don't people like about your product? So they don't like your product, for example, it's too sweet. So you reduce the sugar. So you respond to the sentiment. It's actually, how do we respond to sentiment? So what is sentiment? Okay, sentiment is people believe, view, opinion, conviction. So when we can analyze the sentiment, we can use it for our advantage, right? Isn't it? I mean, agree with me? Okay. So
Yes,
what
sir.
is
Thank you.
Okay, sentiment analysis. How do you apply sentiment analysis? One is voice of the customer. We measure the voice of the customer when they write about our product. And then voice of the market. What is the difference between voice of customer and voice of the market? Voice of the market includes stakeholders. There are government authorities, there are other investors that have also opinion. They also have opinion about your product. So you measure the voice of the market. So in order to get people to invest in your company, you need to know what does the investors think about your company, think about your products. So what do they say about your product? So you measure the sentiments. Voice of the employee, in order to attract good employee, so that in order to attract good people to employ, to apply for jobs in your company, you look into what does the employee say about you, about your company, and then you can use it for brand management, financial markets. You can look into trend, for example, predictive analytics that you say. So we can see, okay, politics. Okay, this is what people are doing now. Politics. We can use sentiment analysis for politics, and also government intelligence. We can use sentiment analytics on government intelligence. So what is the process of sentiment analysis? Is we have textual data. Where does this textual data come from? This textual data came from crawlers. We crawl data from social media. Usually sentiment analysis come from social media or document that people talk about you, and then you calculate the polarity, the objective sentiment polarity. OS is objective sentiment polarity, yeah. And then from the objective sentiment polarity, and then you have the what do you call it? Yeah, this is another polarity, NP, negative positive polarity. Yeah. First, you need to look into objective sentiment polarity, meaning that is there sentiment? No. Is there, okay, yes or no? Yeah. If there is a sentiment, and then you look into the you measure the objective sentiment polarity. Sometimes this is not objective. People doesn't say something, there is no sentiment, there is not objective, so you avoid that. And then you pick up only the objective sentiment polarity. And then you look into calculating the negative and positive polarity, where they talk about you positively or they talk about you negatively. And then you measure whether, and then you use this lexicon. Lexicon is a sort of a dictionary, sense level. Sense level, meaning that it is, when I mean sense level, it means at the right semantic. At the right semantic to define. And then there is another sense level here, lexicon. This you measures the negative and positive polarity, whether you talk about you positively or negatively, and then you tabulate and aggregate the sentiment analysis result. So first you need to have objective versus opinion. Yeah, objective, which is objective subjective polarity, whether it is objective or subjective. Yeah, so we need to just look into objective. We pick up the objective. Opinion is not important, but it is objective that you can act upon. And then you look into whether negative or positive sentiment. And then you have the target identification, and then you aggregate, and then you can tabulate them. Yeah, and then you can measure the polarity, whether it is subjective or very objective or very subjective or positive or negative polarity of your product. What do they say about you, about your company? Okay, any question on text mining and on sentiment analytics? Okay, yes, Jefferson.
So it seems like for sentiment analytics, you really need to know what are the words that governs the sentiments.
Yes.
That is the complexity in it.
Yes, that is the complexity, especially for example, where we can find tools using language. For example, a lot of tools, for example, WordNet and so on, is available for English language. But what is the tools that you find in Malay language or in Malaysia, for example, we have languages that include Malay, Chinese, and Indian mixture. How do you call something good or bad? You combine. Some you say in English, some you say in Malay, some you say in Chinese, some you say in Indian. Jefferson, you're Malaysian, right?
Yes.
You know how do we combine our words?
Yeah.
We mix everything, languages,
slang words again.
And then, so how do you measure such sentiment? So you need to have a glossary for that sentiment. We call it lexicon. We have a lexicon here to put all the sentiments there. So that is the difficult part. Yeah, and then, okay, now we move into web mining. Web is the largest repository. The question by Jaime just now, where do we get the sentiment? Where do you get the repository? Repository we can, for example, in the case of ChatGPT, they build a repository. But there are tools, for example, like Google, they are in charge of the web. They have large web. They do web mining. From the web mining, they can access the web and then they can process. Challenges in the web is a very large repository of data. Data are in text format, HTML, XML, and many other formats. So challenges is too big for effective data mining. Web is too complex, too dynamic, not specific to a domain. For example, we talk about semantic. Semantic is domain specific. Semantic is domain specific. For example, when say you are not allowed to manipulate data, accounting wise correct, but you say IT, we can manipulate data. IT does manipulate data all the time because it's not illegal to manipulate data. Manipulate data meaning that you add data is manipulation. A plus B plus C is manipulation. Otherwise, data is its raw figure. So we add, that is manipulation. We average data is manipulation. But the concept of manipulation applied, that used by people of information technology and applied by people of accounting have different connotation. It means differently. So it's specific to the domain. Semantic is different to the domain. So opportunities and challenges for web mining is very large. And then it involves, so when we talk about web content mining, we have large unstructured data. It's about, they have large unified resource locators. And then we have look into visits, and then it combine all this. Data mining, text mining, we combine into search engine, sentiment analysis, semantic web analytics. This is applications of web mining. Yeah, so essentially web mining is related to text mining as well. We get the data from the web and then we mine the text. Then we still get the same from after mining the text. We do data mining to look into association and so on. Okay, web usage mining, we look into information from data, and then data stored, we look into characteristic usage profile, we look into metadata, clickstream analysis, and so on. Yeah, data stream analysis. So search engine, one thing about search engine, okay, we are short of time, but you can read the notes. Okay, one question I want to ask. Does the search engine search the web? Does the search engine search the web? Anybody? Okay, do search engines search the web? actually search the web?
I think yes. The answer is yes.
Yes.
Yes. Okay, I'll give you the answer straight away. No. It doesn't search the web. Search engine search its own index. They search their own indices. So who search the web? It's actually another robot. We call it crawler. This crawler will go around. There is a term freshness. The term freshness. Yeah, there is a term called freshness. So crawler, when they crawl around, there is a freshness of the index. So once they crawl, they put the date. And then they crawl again, they put the date. So that's okay. And then search engine will search. Okay, we have index, raw index, and then there is a system to organize, to search, to filter the index. So for example, Google have a crawler. Google will crawl. For example, Yahoo will use the Google's crawler. Now today Yahoo use Google's crawler, but Yahoo may have different idea about how to organize their index. They will organize their index, and then once they have organized the index, and then they will search their own index. Yahoo also, although they crawl, but they might have a different idea because their algorithm of searches change every time. They will organize their index according to the way that they want it at that moment of time, and then they will search the index. So that's why when you search, it is very fast. When you search Google, it's very fast because they don't really search the web. The index is already there. Have been done, it's been collected from time to time. Yes, yeah,
Sorry, Prof. Hartman. So in other words, when let's say I go to Google, I say, or any browser like Fox, so then I say, give me the latest news. The latest news. So in other words, it's not the latest news because it's based on their own indexes. So it's not a global news. It's not actually the latest news. But
yes,
so
but
it's their own.
Yes, that's why when you search, sometimes when you search, the site is already down, but you can still look at the cache. Cache is the thing that already in their index, but it's already down on the site. The actual site, it is already down. That is not available in the actual site, but you can still search because it is cached in the index. The cache, there is a cache memory in the index. Yeah, so search engine is actually searching the index, their own index. So search, this is search. Okay, there is 2 cycles here. Can I show here? This is web crawler. Web crawler have schedule. This is what we call freshness. Once they crawl the web, they process and they have document indexer. And then this is cache index. Yeah, and then they will crawl. This is the crawler's activity. And then they put a stamp that is the freshness of the index. So it can be yesterday, it can be last an hour, previous hour. Meaning today is, for example, depends on the time. They crawl all the time. They continuously crawl. This is a non-stopping kind of thing. But when you query, we have a query analyzer which applies natural language processing. They will process your query, and then they will look at the index. And then find the mixed document matcher, and then there is page rank. There is a ranking algorithm. Give the user what they need. So this is the search engine. This is the search part, applying metadata, and then the other part is this is the crawling part. Two activities. And then bear in mind, not all search engine have crawlers. Not all search engine have crawlers, and all crawlers have search engine. Two different business. Some people just develop crawler, but they don't develop search engine. Some people develop search engine, but they don't provide crawlers. But organization like Google, they have both. Depends, yeah. Okay.
Actually, I would like to ask a question. How exactly the search engine will decide on which one is most suggested page? I mean, the first page when we search anything, how it functions.
Okay, there is a term called search engine optimization. Search engine optimization change every time. Yeah. So actually you can subscribe to search engine or SEO magazine or SEO subscription. They will have from time to time how they do their search engine optimization. But basic rule of thumb for Google, for example, which document they put in text. So one is they look at the content. They look at the content. The content must display the semantic of the search. Semantic of the search. For example, you look at here, when you do query analyzer, this is search. So it must display when the ranking here must be displayed the semantic of the search. For example, you put two words. For example, just now I did search. For example, I did root and mathematics. So semantic of the search, root means mathematical roots, not the root in agriculture or tree or plant roots, for example. So identify the semantic of the roots. But how do they know the semantic of the roots, semantic of the document? They look into the whole document and then they look, for example, if you are developing a content about construction, so you must have things about cement, what do you call it, say cement, bricks, and so on. Yeah. So concretes and so on. So so with this, they build up the meaning or semantic of your document. That is number one. Number two is your metadata. You can see here metadata. So you can put metadata. But for example, search engine like Google, Yahoo back then rely on more on metadata, but Google doesn't rely too much on metadata. The third one is on, we call it backlinks. They call it backlinks, hyperlinks that link to you. Hyperlinks that link to you. We call it backlinks. Backlinks is people that link to you. Yeah, meaning that so you are popular when people link to you. So this is the three. And then your how often do you update your site? They can see the last date. So you have how often do you update your site? So this is how you get larger ranking. This is organic ranking, yeah? But the concept is called search engine optimization. Okay. Does that answer you, Shazana? In general?
Yes, ma'am.
Okay.
Prof, so
Yes.
is the backlinks similar to like journal articles that are cited a lot more, is more popular?
Yes.
Is that the same analogy?
Yes, similar. But it is called backlinks. We call it, okay, page rank algorithm. You can see that the algorithm is called page rank algorithm. Page rank algorithm is a backlink algorithm, meaning that you can read the pattern. You can search and get the pattern. It is a backlink algorithm. But when Google started, they apply a lot of page rank algorithm. But today, I discuss with people of Google, they do semantic entailment. Semantic entailment meaning that they also look at the content of your document, entailment, and how often do you update your content. So semantic entailment is the semantic of your content, and then they match against the query. Yeah, that is so backlink algorithm is where your other people's or not other people, other sites link to your site, not you linking out. People link to you, linking in. So it's called backlink. Yeah, linking in. Okay.
Prof,
Yes.
just to be on the SEO part as well, I think the metadata or the description or the images within the website also counts, whereby that would helps with the Google images sites of things. At the same times, when we look at website that have images, it also look at how optimized the images in the portal. For example, if it's a very heavy images file, it might when Google crawl, you wouldn't rank that as very that's what something you call as a page response. So if the
Yes.
page, the website, the portal loads really slow, it will not appear in the top 10 or the first page of Google.
Yes.
And this also applies when you try to search it from mobiles or from your laptop. There's a different algorithm entirely.
Yes.
So if it's not mobile optimized, the portal will not be suggested if you search it on your
Phone.
mobile.
Yes. Okay, that is metadata, yeah. Metadata as well, like I mentioned, so metadata, but not so much of metadata currently, because when you say Yahoo was metadata dependent, but Google they don't really emphasize on metadata. They are more into their backlinks and their meta-entertainment, but they still look at metadata. Their concern on metadata is people put bad metadata, meaning that you try to promote your product as if it is something else, and then you put metadata in it. You put metadata, so it can be dubious metadata. Metadata is something that you put in yourself. But Yahoo, for Google, they don't really trust metadata. I've interviewed people. I met some of them when I was when I met some of them in Google, and then they say they do look at metadata, but they don't really rely on metadata because people put metadata. It's actually how do you want to portray your content. How do you want to portray your content? You put the metadata, but they don't trust metadata actually. Okay, anything Hakimi? Anything more that you can add?
That will be good, Prof. That's
Okay.
about it. Yep. Thank
Okay. And then now is the search engine. Okay, like I mentioned, there are two cycles in the search engine. One is the development cycle, which gather the index, and then the response cycle, which actually respond to your query from the index. So they don't really search the web. So if you search the web, it will take a long time. So, but the index is already there. So index have been organized by the search engine. And then these crawlers have what we call it robots.txt, not crawler. Crawler have this file called robots.txt that carries the identity of the crawler. So they can allow you to come in, or they don't allow you to come in. Yeah. So this crawler, and then this is search engine optimization. This is the question that you asked just now. So it depends on how do they look. If they look into content, HTML, keyword, external link, yeah, and also metadata. Okay, I think this we were already 10. I think you can go through this on your own, yeah. Okay, before we social network. I think nothing much on social network. Social network and social network. What is the difference between social network and social media? The rest you can go through, but I want to check your understanding on social network and social media. Anybody? What is the difference between social network and social media?
Social network is the connectivity from an individual's point.
Yes. Social
And
network
media
is from
just the data lah. It's just the
social
information.
media is on your media. The relation that is the software is the combined. Yeah. So you know that social media is what we call Web 2.0. Yeah. Social media web is Web 2.0. And then social network is the network. Social media is like where we have co-creation, customer put in content instead of the owner of the server put in content. Whereas social network is the network of humans. Okay, we are 10. We are okay. We are now 10:05. Okay, any question before we adjourn? Any question? Aimi, Ivan, Nadira, Hakimi, Jefferson?
None
Share
from
it.
me,
Not for
Prof.
me, Prof. Thank you.
Okay. Okay, otherwise, okay, we can adjourn for today and then we'll meet again next class.
Okay.
Thank you.
Thank
very
you,
Okay,
Prof.
Prof.
Thank you, Prof.
Thank you, Prof.
Thank you, Prof.
Thank you,
Thank everybody.
Prof.
See you, everybody.
Thank you, Prof.
Yeah.